I'm Meg Seashon here at Intersolar North America in San Francisco, California. Here with me today is Marc Thomas, CEO of Dysol. Welcome, Marc.
Thank you. Good to be here, Meg.
Today you spoke in a session about the advancements in BIPV, Building Integrated Photovoltaics. Can you give me a brief rundown of the market and how it's advancing?
Well, overall, the market's advancing fairly slowly but steadily. BIPV is a very challenging area because it's not readily made and readily available for products to be integrated easily into buildings, and there are still a lot of challenges. The challenges range everywhere from standards and codes to negotiating with unions to who does what. So the market is still very young and it's very promising.
Can you describe DSC technology and how it compares to traditional PV in both costs and efficiency?
Sure. Dye-sensitized solar cell technology is a nanotechnology that's biomimeric in nature, often referred to as artificial photosynthesis. And the technology itself is, has some unique capabilities and some characteristics. The first and probably the most important is its ability to generate energy in low light and diffuse light environments. And what that means is the technology has the capability of collecting light in non-optimum, non-ideal scenarios. For example, perhaps on the north side of a building or in somewhat of a shaded environment. So DSC, when applied to traditional building materials such as glass or metal, allows a building to become a power generation station and produce power from all four sides of the building and from all surfaces, assuming it's made out of metal or glass. And that's one of the unique characteristics of DSC. The other is it has low embodied energy, which means that the amount of energy required to produce the technology is actually very low, and the energy payback period is very short, anywhere between 1 and 3 years or less in some cases.
Where are the major growth areas for BIPV, and which markets can benefit the most from this technology?
Well, the technology being able to be applied to glass and to metals, the primary market is in building facades and glazings. So as we look around us here in this beautiful environment and we see all this glass, what's missing is the glass is just being glass. It's not being photovoltaically active. And although it's making a contribution to the building, the foundation of the building or the facade of the building, it's actually not producing power. Now, it may be conserving energy, which is great, but our intent and our goal is to take this DSC technology and turn these buildings into actual electricity generators.
Now, how is the sector working towards grid parity, and where do you see it going in the next 5 years or so?
Well, one of the areas that I feel BIPV has an advantage over almost all technologies is in getting towards grid parity. And when I talk about grid parity, I reference kilowatt hours per dollar spent, or cents per kilowatt hours, just like the way you pay your electric bill. Right. We all pay it by cents per kilowatt hour. And we should measure the efficiency and the effectiveness of the technology. And one of the cost contributors to the technology is, let's say, installation. Well, when you look at the building around us, the glass is already there. So when you build a building, the cost of installing the glass exists. Well, wait a minute, you put glass in there and your substrate's glass, and you already paid for the glass and the cost of the building, and you had to put it anyways, so then your BIPV panel's glass is now covered in the cost. And there's a third, you have to transport the glass to the building site, or the metal facade for that matter. You have to transfer the glass, transport it. So you've got trucking costs and transportation costs. Well, wait a minute, you have to do that anyways. So when you start taking a look at the cost dynamics of a BIPV system, and currently there's no formal way of evaluating it, as there are for ground mounts and other types of BIPV or utility scale technologies, you find that the cost economics, half the cost is already burdened in the cost of the building. Substrate, putting the glass in the building or the metal in the facade, and bringing the materials to the building site. So the economics are very compelling, and that drives down the cost, the LCOEs, and the cost per kilowatt hour.
Okay. Well, thank you so much for being here, and enjoy the rest of the show.
Well, thank you, Meg. It was a pleasure.